In this video, we're going to look at how to balance chemical equations. So I have an example up here on the screen right now where we have H2, which is hydrogen, plus Cl2, which is chlorine. And when these two react, the reaction yields HCl, which is hydrogen chloride. Now, there's a problem right now with the way this equation is written, and I'll show you what the problem is by bringing in some animations. So here's H2. Now, H subscript 2 means that you have two hydrogen atoms bonded to each other. So that's what's drawn here. We have two hydrogen atoms touching because they're bonded together. Now over here, the Cl2, we need two chlorine atoms, again bonded together. And notice the colors match. Over here we have the arrow, which means yield, so we have the reaction happening. And I've drawn this dashed vertical line here to kind of separate the reactants, which are over here, from the products, which are about to appear over here. So the product here is H bonded to Cl. The problem is it's not balanced. According to the law of conservation of mass, if you have two atoms on the product side, there should be two atoms on the reactant side. Well, let's take a look. Let's take a look at the reactant side for hydrogen. We have two atoms of hydrogen here on the reactant side. Go over here to the product side, there's only one atom of hydrogen. That's a problem. It's as if a hydrogen atom has disappeared. Chlorine has a similar problem. We have two chlorine atoms on the reactant side, but only one on the product side. So to fix this, there are a few rules we have to follow. You can only add things. For instance, you could add another H2 right here, which I'm circling around here with my cursor. I could add another Cl2, which I'm circling here, or I could add another HCl. I'm not allowed to take anything away. And I'm also not allowed to add parts of molecules. I can't just add a single H atom or a single Cl atom. So given those constraints, the only thing I can do here to make this balance, the only thing I can add is to add another HCl, which I'm doing right now. I've brought in another molecule of HCl. Now notice again, the H and the Cl are bonded together, so they're touching, but this HCl molecule is not in contact with this other one. There's some space in between to show that they're separate. They're not chemically bonded together. Let's check to see if this is balanced. So over here on the reactant side, we have two hydrogen atoms. On the product side, we have two hydrogen atoms. On the reactant side, we have two chlorine atoms. And on the product side, we have two chlorine atoms. So yes, it is balanced now. And we need to make a coefficient appear in front of HCl. So let's bring in a coefficient, a 2. The 2 in front of HCl tells us we have two molecules of HCl here. There's no coefficient in front of Cl, so that means there's just one molecule of Cl2. And there's no coefficient in front of H2, so that means that there's just one molecule of H2. And we have now balanced this chemical equation. We have the same number of atoms of hydrogen on the left side, the reactant side, as we have on the right side, the product side. And the same thing is true of chlorine, same number on both sides. Notice the way you balance chemical reaction equations is to put a coefficient or coefficients in the proper places. We never change these subscripts. You cannot change these small numbers here. The 2 here or the 2 here cannot change. Also, you can't put a 2 between the H and the Cl or a 2 afterward, because if you did, you would be changing the chemicals into different chemicals, and that is not allowed. Let's take a look at another example. Here we have calcium plus water are reacting and yielding calcium hydroxide and hydrogen. So calcium is all alone, a single atom. Here's H2O. Now for calcium hydroxide, it's a calcium atom. And notice the OH here is hydroxide. It's in parentheses. So we're going to bring in an OH in contact with the CO, so it's Ca, so it's bonded to it. But there's a 2 after the parentheses, which means there are actually two OHs, two hydroxides, so I'll bring in another one here. So here we have an OH, a calcium, and another OH. So because you have two OHs, this makes sense. The OH in parentheses has a subscript 2 after it. Now, I just want to warn you here, a little bit of a caution, is that in actuality, the calcium hydroxide is not arranged with all of its atoms in a straight line like this. They're not all connected exactly the way shown here, but that's okay because right now we're not concerned about exactly how these atoms are bonded to each other and exactly what shape it has. It's all right for us just to put them all in a straight line because today we're just counting atoms and counting molecules. So let's go on to H2, and here we have the H2. Now looking at it, I can see it's not balanced. For one thing, there's only one oxygen atom on the reactant side, but there are two on the product side. Another problem is on the reactant side there are two hydrogen atoms, and on the product side there are four. 1, 2, 3, and 4. So remember, the only thing I can do is add more of something or some things. And I can't add anything except these four options here. I could add more calcium, I could add more water, I could add more calcium hydroxide, or I could add more hydrogen. And by hydrogen I mean a hydrogen molecule. I can't just add a single atom of hydrogen. I would have to add another molecule, H2. Well, because I have too little oxygen over here on the reactant side, I can tell right away I'm going to need more. And the only way I can get more oxygen is to add another H2O molecule. There we go, another water molecule. Now this has helped because now I have two oxygen atoms here, 1 and 2, which matches on the product side where I have 2. The hydrogen situation is better now as well because I have 4 hydrogen atoms over here on the reactant side, and I also have 4 over on the product side. And even my calcium situation is now fixed. I have 1 calcium atom here on the product side and 1 on the reactant side. So it turns out this chemical equation is balanced as long as I put a coefficient of 2 in front of H2O. And so now I have a balanced chemical equation. Ca plus 2 H2O yields Ca parenthesis OH parenthesis 2 plus H2. Next, let's see another example. N2 is nitrogen. So here we have N2. H2 is hydrogen. Together, they react and yield ammonia, NH3. Well, I see a problem. It's not balanced. I have 2 nitrogen atoms here, but only 1 over here. So I definitely need more nitrogen over here on the product side. I cannot add just a single nitrogen atom, but I can add another NH3 molecule. Now I've fixed the nitrogen problem. I have 2 nitrogen atoms here and 2 over here. However, I still have a hydrogen problem because on my reactant side I only have 2 hydrogen atoms, and on the product side I have 1, 2, 3, 4, 5, 6. But this is fixable. I just need some more hydrogen. So here's another hydrogen molecule. Now I have 4 atoms of hydrogen on my reactant side. Let's bring in another hydrogen molecule. And now it's balanced. I have 6 hydrogen atoms on the reactant side and 6 hydrogen atoms on the product side. 2 nitrogen on each side. So I do not write a number in front of N2 because there's just 1 molecule of nitrogen, but I do need a number in front of H2, and that number is of course called the coefficient, and I need a 3. And in front of NH3, which is ammonia, I need another coefficient. I have 2 molecules of ammonia here, so I need a coefficient of 2. And now I have a balanced chemical equation. N2 plus 3H2 yield 2NH3. And that concludes this video.